So, welcome back. Um, Let me recap our last discussion. So, by now, you are aware of what is binary search, why binary search is important to understand, how does it work in principle, what is the prominent application of binary search. Now, coming back to this video agenda, our agenda here is as follows. Let's try to understand binary search with a better subdivision. It has three divisions. The first one is pre-processing. Binary search only worked on sorted data. So the data sets need to be sorted in case not already sorted. This is the first division. The second division is binary search using a loop or recursion to divide search space in half after each comparison. And the third division of this binary search is post-processing, determine viable candidate in the remaining space. Now we'll discuss many detailed information about these templates, these different division, how these divisions work, play in different kind of templates. So introducing the different templates of binary search. So to simplify the binary search understanding, I'm going to cover three different templates which will cover all the different possible implementation of binary search. So let's start with template one. The first point here is how to identify that it will fall under template one. The key characteristics here are, number one, your search problem coincides with the elementary form of binary search. Okay. I can understand that you are confused with the term elementary form statement, but I request you to bear with me until the point I will show you an example of this type of problem. So bear with me for some time, okay? It is coming very soon. The point number two here is search condition can be determined without comparing to the elements never, or using a specific element around it. And the point number three is no post-processing is required because at each step you are checking to see if the element has been found. If you reach the end, then you know the element is not found. So these three listed key characteristics will make sure that your problem falls under template one category or not, right? So if these three characteristics exist in a problem, then you can say that this problem fall under category one. So by now, I'm assuming that you will be able to identify the problem and it falls under template one. So let's list down some key implementation struct to avoid any such boundary case leakage under this template. So once you identify the template, now there is just some standard solution struct is there. You have to understand that, and you should always take care in your solution. That's it. If you follow these things, once you identify the template and you follow the solution struct in your solution, no deal to that. It has to be 100% correct. So the point one is initial condition like left is equal to 0 and right is equal to length minus 1. The second solution struct is termination point is left is greater than right. And if you want to search in left side, then you have to set right is equal to mid minus 1. And if you want to search in right, then left is equal to mid plus 1. So these are the solution struct you have to take care if you identify the template type. First type of template one type. So enough theory now. Let's move to the coding part, and let's see how you can identify the template type 1 and how you can write your code by just following the solution struct, which I just explained you right now. Let's move to the coding part now.